Okay, so today I want to continue our discussion of nucleophilic substitution, but now transfer to reactions that proceed via a unimolecular transition state. So this is known as SN1, where there's one molecule involved in the rate-limiting step. So SN1 is going to generate a product that looks similar to SN2. The nucleophile will replace the leaving group. However, the mechanism is fundamentally different. The first step has no involvement of the nucleophile. We simply dissociate the carbon-leaving group bond. So, of course, generating a carbocation, if a carbocation forms in the reaction mechanism, that step is slow and rate-limiting. It is endothermic, always requires energy input to break a bond, no matter how strong or weak that bond was. Next, carbocations, of course, are highly electrophilic, and they have empty p orbitals, or a single empty p orbital. And the nucleophile attacks. And now it is in place of the leaving group. So it looks similar to what we had from SN2 in the result. We'll talk about some stereochemical differences, but the mechanism is now 2 steps instead of 1. Assuming it's exergonic, carbocation formation is slow, and nucleophilic attack is fast.